if you have so we ended up with v squared equals minus n squared x squared plus k, right? But we could make this any constant. We could choose any letter here. So it might be a bit weird to have a square number equal to something that looks negative, right? So maybe we could choose this constant to make it sort of, because this constant's obviously the thing that's going to make this part negative, and then that'll make it positive when you times it. So you can just make it a minus a square number to make it like obviously negative. So the x squared minus say alpha squared, right? Okay, and then you can make it look more positive by making it n squared alpha squared minus x squared. Yep. Okay, so there's some issues that have come up, but I'll just name them, but I won't necessarily deal with them. So you take this, you can take a square root here. And you know, like we know it's going to be continuous, so it's going to be one of the plus or minus the whole way, but we might not know which unless we have initial conditions or some specifics of the situation. So we'll just kind of have to keep that in there. But you know, this dealing with one of them will be the same as dealing with the other one. So we'll just keep it plus and just put a minus sign in when we deal with the minus. You know? Okay. So then, what we did was we want x now in terms of t. So we got dx dt equals n square root alpha squared minus x squared. And we're trying to appeal to this integration by substitution idea, which is f of x dx dt equals f of x dx. Okay, so it looks like the dt's cancel even though it's more the chain rule thing again, right? Okay, so one thing we could do is we can't just integrate this straight away, right? Because this is with respect to t and there's only x's here. So we can put all the x's together and make it look more like this. So, for example, we divide, so we have 1 over the square root of alpha squared minus x squared dx dt equals n. You know? And then to get it to look like this, we can integrate both sides with respect to t. Okay, and so the rule here tells you that this is just 1 over square root alpha squared minus x squared dx. And then this is just nt plus a constant. Okay, so then the question boils down to how do we evaluate this integral? And if it's some sort of inverse sine or sine, then we'll end up showing that x is a sine function of t. Okay.